Welcome to the review and preview problems 9-20 to 9-27 in the CCG book. 9-20 says, Mr. Wallace is designing a home. He found the plan for his dream house on the internet and printed it out on paper. The design of his home is shown below. If all measurements are in millimeters, find the area of the diagram. So when we look at this diagram, we can divide this up into several different shapes. So I can create a right triangle and use my trig functions to find this missing piece at the bottom. So the trig function that uses adjacent and hypotenuse is cosine. So if I take the cosine of 60 degrees, it equals my adjacent side over my hypotenuse. I then want to multiply my trig function, which tells me that x is 15. I then know that all three of these pieces are congruent, so I can take 51 and subtract 15 from it, and I know that I am left with 36 for this distance. So I know that 36 divided by 3 gives me a distance of 12 units. I then know that this piece is also 12, so I can use my trig functions again to find my opposite side. So sine uses opposite, so the sine of 60 degrees is equal to my opposite side over 30. My inverse operation is multiplication, so 30 times the sine of 60 is equal to about 26. So if I know that this whole distance is equal to 26, I need to subtract out this 12. And I would get approximately 14. So this piece down here would be 14. I then want the shape of my home, so I could do the shape of this entire big box, which would be 26 times 36, which equals 936 millimeters squared. But I need to subtract out this piece, which would be 12 times 12. So we need to subtract out 144. Which would bring us to 792. And then we need to add our triangle, which if we take 1/2 times our base, which is 15, times our height, which is 26, we get 195. We then need to add 195 in, so we get an area of 987 millimeters squared. Mr. Wallace took his home design to the copier and enlarged it 400%. What is the area of the diagram now? How do you know? So when we know that it was enlarged by 400%, we know that that means 4 times as large as our original drawing, which we say was at 100%. what is the area of the diagram now? Well, if we know that it was 4 times as large, we know that area is a scale factor squared. So we need to multiply our area of 987 by 4 squared, which would be 16. So when we multiply that, we get approximately 15,792 millimeters squared. Below is a solid from problem 9-7. View it isometrically using the e-tools. On graph paper, draw the front, right, and top views. So in order to draw the front view, I'm going to draw that in pink. Remember, it's what blocks do we visually see? So on the left-hand side, I see 3 blocks. Looking back, I see this block and this block, so I would see 2 blocks. And then on this front view, I see 1 block. So those were all my front views. When I draw my right view, I see 1 block in my first row on the left-hand side. I see 2 blocks in the middle. And I see 3 blocks on the end. When I draw my top view, I'm looking down, so I see 1, 2, 3 blocks on my left. I see 1, no block in the middle, but 1 on either side. And then I see 2 blocks right here. So this one is not a block. And this one is not a block as well in the corner. Find the total surface area of the solid. So if I find the total surface area, I want to take all of my blocks from the top, 1, 2, 3, 4, 5, 6, 7. Add all of my blocks from the bottom, which would be the same as the top, so 7. Then I need to add all of the front side of my blocks. Then I also need to add the back sides of my blocks. So the front side would be 1, 2, 3, 4, 5, 6. The back sides of my blocks would be 1, 2, 3, 4, 5, 6, 7. Because I gotta account for that bottom box. My right side would be 1, 2, 3, 4, 5, 6. My left side would be 1, 2, 3, 4, 5, 6. Then I also need to account for these four sides inside here of this opening, which I accidentally added one more to my back view on accident. So I have a total of 42 units squared. Nine 22 says review what you know about the angles of a polygon below. If the exterior angle of a polygon is 29 degrees, what is the interior angle? Well, the exterior angle plus the interior angle of a polygon is equal to 180 degrees. So if we take 180 degrees and subtract 29 degrees out, we get the interior angle of our polygon is equal to 151 degrees. If the interior angle of the polygon is 170 degrees, can it be a regular polygon? Why or why not? So when we think about the interior angles of a polygon, our interior angle, our central angle, is 180 minus our interior angle, which in this case would leave our central angle to be 10 degrees. We then know that the central angle is equal 360, and we know that 360 is divisible by 10, so it goes evenly, so we would have a 36-sided polygon. So a polygon with an interior angle of 170 degrees is a 36-sided regular polygon. Letter C says find the sum of the interior angles of a regular 29-agon. So if we have a 29-agon, we have a polygon that has 29 sides. So we had two different methods we used. If we made triangles in our regular polygon, we took the number of sides, subtracted 2 from that, and then multiplied that by 180, which gave us 4,860. We also took 29. The other method is if we formed central angles, 29 central angles. So we take 180 times 29 sides, which gives us 5,220, and then we subtract our central angles of 360 from that, and we also get 4,860 degrees for the sum of our interior angles. So either of these methods would work. For each geometric relationship below, write and solve an equation for x. So looking at this polynomial below, I need to find out how much the interior angles add to. I notice that I have 3 triangles, so I know my angles, 4x minus 3 plus 7x minus 6 plus 3x plus 12 plus x plus 10 plus 2x all add up to 540 degrees. When I combine my like terms, 4x plus 7x plus 3x plus x plus 2x equals 17x. Negative 3 minus 6 more plus 12 plus 10 equals positive 13. Our inverse operation of adding 13 is subtracting 13. So we get 527 is equal to 17x. Divide by 17, and we get x is equal to 31 degrees. Looking at letter B, I know that vertical angles are congruent, and I also know that if we have parallel lines, corresponding angles are also congruent, which means that 4x plus 20 plus 5x minus 2 forms a straight line that equals 180 degrees. So 4x plus 5x gives us 9x. 20 minus 2 gives us 18. The inverse of positive 18 is negative 18. 9x is equal to 162 divided by 9. X equals 18 degrees. At the band's peak of popularity, a personally signed black diamond poster sold for $500. 3 years later, the band was almost forgotten and the poster was worth only 10. What were the annual multiplier and the annual percent of decrease? So we know at the band's peak, it was worth $500. And we know that 3 years after that, it was worth $10. So when we write an exponential equation, we use y equals ab to the x power. So in this case, we know that our initial amount, or our a, was $500. We are looking for our b, or our multiplier, and we have an x and a y value from this other ordered pair that we were given. So we can replace our y with 10, we can replace our x with 3, and we can use inverse operations to solve. So when we divide by 500, and we get 1 over 50 is equal to b cubed, the inverse of cubing something is cube rooting it, so we get b is approximately 0.2714. So when we look for the percentage of decrease, we want to take 1 and subtract 0.2714 from that, which gives us approximately 72.9% decrease. So 9-25 says on graph paper, triangle ABC. So A is at -3, -4. B is at -1, -6. C is at -5, -8. What is the length of line segment AB? So if we draw our slope triangle in, we have a distance of 2 and a distance of 2. So we can use the Pythagorean theorem, 2 squared plus 2 squared equals c squared. So 4 plus 4 gives us 8. And when we take the square root of 8, we get 2 times 4, 2 times 2. So we get our distance c is equal to 2 roots of 2 units for our distance of A to B, so 2 root 2 units. It then said reflect ABC across the x-axis to form A prime, B prime, C prime. What are the coordinates of B prime? Describe the function that would change the coordinates of A, B, and C to A prime, B prime, C prime. So in order to change the coordinates, we would take our XY ordered pair and simply change the sign on our Y value. Our X would be the same. So our new ordered pair for A, our X would remain the same at -3. Our Y would become a positive 4 units from the X-axis. Our B, -1, would remain the same. Our 6 would now become 6 units from the Y-axis. So our A would be 4 units from the Y-axis. And our C would become 8 positive units from the Y-axis. So C would equal -5, +8. Rotate triangle A prime, B prime, C prime 90 degrees clockwise about the origin to form A double prime, B double prime, C double prime. What are the coordinates? So when we are rotating 90 degrees clockwise, this time our X values are going to change, but our Y values are not. So our X value in A is going to become +3 units 4. Our B is going to come +1 unit 6. And our C double prime would become 5 +8. Translate triangle ABC so that XY goes to X plus 5 and Y goes to Y plus 1. What are the new coordinates of point A? So looking at this, when we look at our original A, B, and C, we are going to add 5 to our original A, our X value of our A. So -3 plus 5, Y plus 1 would give us an A coordinate of 2, -3. If we went on to find the rest, B would be 4, -5. And if we also found C, it would be 0, -7. 9-26 says compute the volume of the figure below. So the first thing I want to do is start filling in some missing pieces, drawing in some lines. I notice that I have 2 different rectangular prisms here. If this is a length of 4, I can subtract 4 from this 10, and I know that this is a length of 6, and this is a length of 4. If I know this side is 6, and this is 3, I know that this is also 3 centimeters. If I know this side is 5 centimeters, I know this side is 5 centimeters as well. So to find the area of this rectangular prism, I'm going to do length times width times height. So 4 times 5 is 20 times 3 gives me 60 centimeters cubed for the volume of the blue piece. If I then find the volume of the pink piece and add them together, I know that my length is 6, my width is 5, so 6 times 5 is 30, times my height of 6 gives me 180 centimeters cubed. I then need to add those two together, so I get a total of 240 centimeters cubed. Multiple choice, find the perimeter of the sector at the right. So knowing that this could be formed into a right triangle, and my hypotenuse is 6. If I divide this angle in half, this is 15. I can determine what my height is. So the trig function for that would be adjacent and hypotenuse. So cosine is adjacent over hypotenuse. So the cosine of 30 degrees equals my adjacent side over my hypotenuse, which is 6. I multiply both sides by 6, which gives me approximately 5.2. I then need to find my base, so the sine is opposite over hypotenuse. The sine of, I used 30 degrees in the previous one. We need to change that to 15, which changes this to approximately 5.8. Then if I do the sine of 15 equals the opposite over my hypotenuse of 6, 6 times is 1.55. So we did all that work, and that would give us the base and the height, which would be to find the area. But in this case, they asked us to find the perimeter. So if we know this side is 6 feet, we know that this side is 6 feet. We know that if this angle is 30, our whole circle is 360. So if we divide 360 by 30, we know that the circumference of our circle is 2 pi times the radius. So the circumference is equal to 12 pi. 360 divided by 30 tells us how many sides it has. So it has 12 sides. So if we take the whole circumference and divide that by the number of sides, we know that this piece right here is pi. So when we add up 6 plus 6 plus pi, we get d 12 plus pi feet as our perimeter.